Okay, new unit on quadrilaterals. So we're starting off with a parallelogram. A parallelogram, remember, quadrilateral, quad means four sides. Literally, because lateral means sides, so this literally means four sides. So a quadrilateral that has opposite sides parallel. And I'm just going to write the symbol to save time. So opposite sides are parallel in a quadrilateral. And remember, we use like little arrows to show parallel sides. You can jade them in or whatever you want to do. Okay. Just use different numbers for opposite sides. So 1 and 2. It does not have to correspond 2 for the bigger side. It doesn't really matter. You can do whatever you want. So, if you had these tools, you could take a ruler and measure the opposite sides and angles and so forth. So are the opposite sides congruent? Yes, they are. Okay, you can measure this with a ruler and prove it. Are the opposite angles congruent? Yes, they are. So let's go ahead and mark that right now. So I'm going to mark these two sides congruent and these two sides congruent. This angle is congruent to this angle, and these two are congruent. All right? Are the diagonals congruent? Well, you can kind of tell from here to here. That's a big old fat one. And from here to here, those are not the same length. You can take out a ruler and measure this to prove it, but they are not the same length. Okay, the red one is longer than the hot pink one. So the answer is no. Are the diagonals perpendicular? Do they form a right angle? No. You clearly see they form obtuse and acute vertical angles there. They do not meet at a right angle. So that's no. Do the diagonals bisect each other? Yes, they do. So what that means is this piece, they bisect right here. They cut each other in half. Those are equal to each other, and these two are equal to each other. Those sections. Do they bisect the angles? No. So this angle right here is not bisected by that line. And this angle here is not bisected by that diagonal. Are all the angles right angles? No, you clearly see that. Are all sides congruent? Not necessarily. It does not have to be. Okay, a rectangle. A parallelogram that has so a rectangle is a parallelogram that has four right angles. Okay? So it's everything the parallelogram has plus the four right angles and congruent diagonals. So, are the opposite sides congruent? Yes. Are the opposite angles congruent? Well, yes, because they're all 90. Are the diagonals congruent? We just said that. Are the diagonals perpendicular? No, they are not. So let's go up here and mark some stuff. So here's one diagonal. Here's another diagonal. They are the same length. But you can tell, again, they do not form 90-degree angles. They form two obtuse and two acute angles. But opposite sides are equal. Opposite sides are also parallel because it is a parallelogram. Right? Opposite angles are equal, and they're all the same because they're all 90. Do the diagonals bisect each other? Yes, they do. So again, we can come up here and say, those are equal, and actually they're all equal because since the diagonals are the same, all four segments are the same. Do the diagonals bisect the angles they come from? No, they do not. Are all the angles right angles? Yes, they are. Are all sides congruent? No, opposite sides are congruent. Now we have the square beyond compare. So it has four right angles and four congruent sides. So the square has all the properties of a parallelogram. But it has four right angles. Congruent sides. And congruent diagonals. So, let's look at this. Are opposite sides congruent? Well, yeah, all the way around. Are opposite angles congruent? Well, yes, because they're all 90. Are the diagonals congruent? Yes, they are. Are the diagonals perpendicular to each other? Yes, they are. So once we get to a square, now it's special. Do the diagonals bisect each other? Yes, because they are equal. Do the diagonals bisect the angle they originate from? Yes, they do. Are all the angles right? Yep. And are all sides congruent? Yes. So let's go do some marking up here. Opposite sides, all sides equal. It is a parallelogram. Horrible triangles, but you know what I'm getting at. The diagonals are equal to each other. They bisect each other. And they intersect at right angles. So, very special property. And again, the angles on the corners are bisected. So, they're split 45. So, if you notice, each of these triangles is a 45, 45, 90. Four isosceles triangles. Okay, the rhombus. Okay, the rhombus has four congruent sides. All right? Now, rhombus has the properties of a parallelogram. Plus 4 congruent sides, perpendicular diagonals, and diagonals bisect the angles. So, are opposite sides congruent? We guess because all 4 sides are congruent. Are opposite angles congruent? Yes. Are the diagonals congruent? No. And if you come up here and look, obviously this diagonal is longer than this diagonal. Are the diagonals perpendicular? Yes, they are, just like in the square. Do the diagonals bisect each other? Yes, they do. Do they bisect the angles they come from? Yes, they do. All right angles? Nope. All sides congruent? By definition, yes. So again, this angle is split into 2 equal parts. This one is split into 2 equal parts. We have right angles where they cross. That's a rhombus. Oh, I forgot to say, Mark, those are bisected. Okay, a kite. Okay, it's a 4-sided figure. With 2 pair of adjacent congruent sides. So you think of it as usually people think of 2 short sides and 2 long sides. So, are opposite sides congruent? No. Are opposite angles congruent? Now this part's interesting. No, only 1 pair. And it's where the 2 meet. So the long and short side meet here. Those are equal to each other. The top and bottom ones in this picture are not. So only 1 pair of them. Should have a 1 here. 1 pair. Are the diagonals congruent in a kite? No. Now you can see that. Again, you have a long and a short. Are the diagonals perpendicular? Yes. So again, these intersect in the middle at right angles. Do the angles bisect each other? I'm sorry, do the diagonals bisect each other? No. 1 does. Okay, so if you look back up here, that is bisected. Okay? The one that connects the 2 congruent angles is bisected. Do the diagonals bisect the original angles they come from? Again, only 1 does. Are all the angles right angles? Nope. Are all sides congruent? No. Okay, and our last shape is a trapezoid. And a trapezoid is a quad that has 1 pair of parallel sides. So orbital triangle there. This one is parallel to this, top and bottom. And then we have what's called an isosceles trapezoid, which if you think about an isosceles triangle has two sides are equal. Well, we just came through and blocked off the top of it, you know. What do we have? We have an isosceles trapezoid. So these two are congruent, and then these two are parallel. So an isosceles trapezoid has one pair of congruent sides. And they are specifically the non-parallel sides. So real quickly, so for a trapezoid, are opposite sides congruent? No, only for isosceles. Are opposite angles congruent? Now, you know. Are the diagonals congruent? Say no, again, only for the isosceles. So for regular trapezoid, no, but it's isosceles, yes. Are the diagonals perpendicular? Never going to happen on either one. Do the diagonals bisect each other? Not going to happen. Do they bisect the angles? Nope. Are they all right angles? Nope. And are all the sides congruent? No.